Hello and welcome. I'm going to be talking about a problem that affects the Yamaha Motif and some other keyboards, and it's a problem with the key bed. There are a couple of problems that affect keys on keyboards, and one of them is keys slipping out due to wearing of the heel of the key. This is not that problem, this is a separate problem. It affects the Motif and it affects the SY99 and any other key bed that has plastic bases. I'll show you exactly what these things are. When you disassemble a keyboard, and there's a great website that'll help you disassemble a Motif if you're keen and able to work on it yourself. Just Google Motif disassembly, and once you get in there and get the whole key bed out and remove some of the keys that are affected, you'll see, or you may see, this problem. And here we're looking at the plastic bases on a Yamaha Motif. To understand what's happened here, let's look at how a key works. Looking from the side, a key is inserted in a sideways manner, and the spring guide does only one job, and what it does is hold the leaf spring in place, stop it falling out while you guide the key into its position. After it does that job, you don't even need the spring guide. So if you have damaged spring guides, that's okay. You can still, with a bit of fiddling, get your key back in place. The other parts here that are relevant are the base, and the job of the base is to hold the end of the leaf spring and let it pivot there to allow the key to move up and down. There is a gap in the middle of each of these bases, which is only there to allow the spring guide somewhere to go. It's very important that we figure out which parts are functionally fundamental here so that we can design a solution to this problem. So let's have a quick look at the problem. Zooming in, we see a number of damaged key bases. These ones are good ones. These ones have clearly been damaged, and it's basically just the plastic deteriorating and snapping off in places. Maybe this was due to some keys being hit really hard and the leaf spring making a funny angle or something and breaking them off. But anyway, we've got to replace them because it won't hold the leaf spring in place as it is. Someone has attempted a repair on this one, and I actually tracked down who it was, and it was a reputable keyboard repairer. And so these base parts, these plastic little parts, are not replaceable parts. So what this repairer has done is actually the only thing that you can do except replace the whole key bed at a cost of about $700. And so this guy's taken bits of circuit board and used a screw and tried to create something that will hold the leaf spring. Notice how he's left a gap in the middle for the spring guide to work. This might have lasted for 6 months, I think, and the reason why it failed was the pivot point, which is the place where the spring will get to once it's in place, is further back than the others. And the problem here is that the spring guide is going to start touching that leaf spring because you haven't left enough room if the pivot is further back. This might have just happened because he used 2 bits of circuit board, and over time the edge of the leaf spring sort of wore into that groove and was sticking in further than normal. Okay, but what is necessary is to have a flat surface for that pivot point. Now, as an aside, I find it very amusing to look at this keyboard from the mid-80s, also made by Yamaha, the DX7, which will never have a plastic keybed base deterioration problem because look at its keybed. It is made out of pressed metal. And you can see it does exactly the same job. It's got a flat pivot point, it accepts the leaf spring, and it has a gap for the spring guide. Now let's figure out the best way to solve this problem without having to spend more than the keyboard's worth. Here is the solution that I came up with. You take a piece of tin. Well, the one that I used was for making gutters and downpipes. And this kind of tin is great because you can bend it with your fingers and you can bend it with pliers, but it's strong enough to sort of retain its shape, and I don't think it's going to weaken and break after I've made this. But we'll see. I ended up cutting it in this shape, bending those corners over. They're going to stop the leaf spring from moving side to side. And then bending it fully over on itself to create a little pocket to accept the leaf spring. Then I tried it out with the flat end of the leaf spring that will be living in there, checked the exact angle that best accepts the leaf spring, if you know what I mean. Because, you know, you're just finagling a solution here. You've got to figure out how it's going to work. And so I marked that line on which the leaf spring will pivot, and that's the place where I drilled my hole. And before riveting it on, I cleaned it up a little bit so that it was nice and flat, no rough edges. And then I riveted it onto the keybed. Now you've got to be very careful when you're drilling the hole in the keybed that's going to accept that rivet. Because when you drill through the keybed, you're going to get through to the circuit board underneath. So I'd put something fairly solid, a bit of plastic or something behind, and go very gently with the drill bit when drilling through the steel keybed. You can see where I've positioned my new base or leaf spring acceptor. I'm not sure what the actual word is for that part. You can also see in this picture where I've removed the other three deteriorated plastic parts to make way for more of the same solution there. And there's a close-up of it. Now you'll notice I paid a lot of attention to making sure the back of that pocket in the base that I've made is in line with the place in the other bases where the leaf spring will get to. This means that I can still keep my spring guides on the keys. The spring guide will simply slip behind my tin base and won't touch it. You'll also notice I had to bend down the end, the pocketed end of my piece of tin into the hole a little bit just to get the angle just right. I hope this works for you. It certainly worked for me. I put my keyboard together and it was just brilliant. Now, just thought I'd mention also, when you are taking keys out and reinserting them, you have to be very careful of the key contacts. If you get the angle right, you won't touch the key contact when you insert the key. The key contact can be seen down the bottom of this picture. But if you get the angle wrong, the key, and that's the white bit here in this picture, will bend the key contact in the wrong way. So this key has been inserted incorrectly. It needs to be removed, and then the key contact needs to be bent back to match the others. If you try and operate the keyboard with key contacts that aren't the same as the others, that key will have a different velocity scale. Okay, so in other words, it will be softer or louder than the others and won't respond the same. So you need to check your key contacts. And when you put your keyboard together and try it, if there are any problems, the upside is you don't actually have to take out all the circuit boards and things to get to the keybed anymore. You can actually get through from the back just by taking the back cover off. All right, so good luck with that repair. I hope it's been helpful. I really do think that although it seems like a sort of cowboy solution, it really is the only solution bar replacing the whole keybed.